This naturalrefrigerants.com article is being read by an automated voice. SCM Frigo continues expansion into Megawatt-Scale Industrial CO2 Systems with 1.5 megawatt pharmaceutical installation. By Christina Hayes. Published July 11, 2025. Italian manufacturer SCM Frigo has strengthened its presence in the industrial refrigeration sector with the deployment of a 1.5 megawatt, 426.5 tons refrigeration transcritical CO2 rack system at a cosmetics and pharmaceutical processing facility in France. The plug-and-play system delivers cooling at 6 degrees Celsius, 42.8 degrees Fahrenheit, and includes 1 megawatt, 284 tons of refrigeration, of heat recovery for space heating and hot water production at 50 and 85 degrees Celsius, 122 and 185 degrees Fahrenheit, 185 degrees Fahrenheit, respectively. Additionally, the rack can supply up to 1.3 megawatts, 370 tons refrigeration, of cooling at minus 20 degrees Celsius, minus 4 degrees Fahrenheit, offering broad temperature flexibility for diverse process demands. Designed with a glycol loop and twin unit configuration, the system meets the pharmaceutical sector's stringent requirements for operational safety and built-in redundancy. This is one of our first industrial projects, explained Federica Rossetti, R&D engineer at SCM Frigo, during a presentation at the Industrial Refrigeration Network IRN conference, held June 6th through 7th in Rottenburg am Neckar, Germany. We have brought our expertise in commercial refrigeration and are now ready to provide pre-assembled plants with megawatt power that guarantee easier installation and safer commissioning. While operational data is not yet available due to the equipment's recent installation, theoretical calculations indicate a COPI of around 1.8, Rossetti added. The French installation follows a 6 megawatt, 1,700 tons of refrigeration, CO2 project SCM completed earlier this year at a shrimp processing facility in Ecuador. Efficiency optimization. The customer initially requested a flooded technology for the medium temperature, (MT) load, and direct expansion, DXE technology for the low temperature, LT load. But after a discussion, SCM Frigo proposed a simplified approach that used DX with glycol for both MT and LT applications. This configuration improved operational efficiency and reduced system complexity without sacrificing performance, Rossetti noted. To ensure the customer's requirements were met, SCM Frigo deployed a number of advanced technologies and tailored design strategies. 2 parallel liquid ejectors to improve performance in the system's MT section by recovering flash gas and reducing compressor load. A shell and tube heat exchanger ensures proper superheating of refrigerant vapor while minimizing suction pressure drop to protect compressors from liquid slugging. An internal heat exchanger used in the LT section to subcool liquid refrigerant and maintain low superheat, increasing cooling capacity and evaporator efficiency. A dedicated bypass circuit ensures precise superheat control. Custom-built solution. To maintain uninterrupted production during the transition, the new CO2-based refrigeration system was installed in an external container machinery room, allowing the facility's existing HFC-based equipment to remain operational. This approach offered advantages such as simplified planning approval, particularly important given France's strict building regulations, and flexibility for future relocation. However, it also introduced significant challenges related to space constraints, layout optimization, and system accessibility, explained Rossetti. To overcome these issues, designing a compact and well-organized system was key, she added. To address these challenges, SCM carefully optimized the component sizing, system layout, and electrical panel configuration, including custom cable routing to maximize space efficiency and ease of maintenance. The welded steel frame, tailored specifically for the container's dimensions, was developed in collaboration with the University of Padua, which conducted finite element analysis to verify its structural integrity under stress and vibration scenarios.